This is pretty much where we left things off on Monday, where we were looking at the demand and revenue curves of a monopolist versus a perfect competitor. The graph to the left here should look very familiar as the Mr. DARP revenue curves of a perfect competitor. To the right here, we have the demand curve of a monopolist, and as we know, since the monopolist is the only provider or supplier in the market, the demand curve they face is the entire market demand curve, which would be downward sloping. We saw from the activity that this demand curve also equaled the average revenue and the average price. And the monopolist is a price maker. They essentially get to choose whatever price they want, which will give them a resulting quantity. So what essentially a monopolist can pick any point along this demand curve. They just have to live with the consequences of the quantity. So they can set their price wherever they want, but then the market will basically set the quantity for them. Or vice versa, they can pick the quantity they want to sell, but then they have to set the price at what the market will pay for it. The other piece we saw was that the Mr. part of DARP, Mr. DARP, split away from in the monopoly situation. And that was entirely due to this thing called the price effect. So that when we wanted to sell one more unit on this demand curve, the only way to do that is to cut the price. And when you do that, you do sell that extra unit, but then you're forced to take a price cut on all the stuff you had been selling. And so therefore that's what makes the marginal revenue split away from the price. You do get the price for that extra unit, but you lose revenue on the prior sales. And the reason this gap is getting larger and larger is the price cut hurts you more and more the more you sell. When you're up here, you're not selling very much, so the price cut on the prior units doesn't really hurt you as bad. When you're selling a lot of stuff, the fact that you have to cut the price on, let's say, like 1,000 units just to sell one more really digs deep, and that's why this curve starts to split like this as you go. So let's just take a moment to draw out the profit and the profit picture for a monopolist, or the decision-making picture for a monopolist, like we did for perfect competition. So we'll start out by just drawing our price and quantity axes, and then we'll draw the revenue curves in. So the first thing we'll have in here is DARP. That's the downward sloping demand curve that a monopolist faces. We'll from there add the marginal revenue curve, which we've said a few times now has to be below DARP because of that price cutting effect when you want to sell more quantity. And from there, those are the two revenue curves for monopoly. And the next step is just to do the same thing we did for perfect competition, is to throw the cost curves on there and see what happens. So the cost curves look the same for a monopoly as they do for a perfectly competitive firm. So everything we've learned about cost curves will carry over to monopolies. So the first thing we'll do is we'll throw our Nike swoosh marginal cost on there, and then we'll throw an average total costs, which you can see marginal cost swooshes through the minimum of ATC, no different from monopoly. So here we have the cost curves and revenue curves for a monopolist, and the process for finding the profit maximizing output is no different. If I were in class, I'd be walking under the optimal output rule. So how does a firm decide how much to sell? They maximize profit, and that always happens where MR equals MC, no different from a monopolist. So we're going to see where the light blue curve intersects the red curve, and it's going to be right there. I'll label that point A, and so that's where MR equals MC, and that determines our optimal production point for maximizing profit. So I'll go ahead and draw that in. We see down at the bottom here a Q star, which is our profit maximizing output, and that's what we're going to produce. Now all that's left is to really determine the level of profit that this firm is going to make. So the first thing is, if we're producing a Q star, what are they going to charge their customers? Well, they're going to go all the way up to the demand curve. That's the highest they can price it at, so they're going to price it at the highest point. Anything lower would be suboptimal, so they're going to price it right there where the Q star line hits the demand, that's point B. If we trace that over, that's the price that they'll charge. Then we have to go to the cost side of things to see what the profit is. So to find the cost, the average cost, we'll, just like perfect competition, we're going to see where the Q star hits average costs, which is the intersection there with the purple curve. Go ahead and label that point C, trace that over, that's our average total cost. And then what we'll see is this opens up a profit rectangle box for us that we can analyze, and that's going to be the profit per unit here. If you take price minus ATC, because price is average revenue minus average cost is average profit, and then we can just figure out the profit by looking at how much we sell per unit, and if we go ahead and shade that in, that's the profit earned by this monopoly. So one thing that's interesting is this profit cannot get competed away. We saw, and we know in perfect competition, if there's profits, that means businesses come in, take it, and basically take it away from you by entering. Perfect monopolies have perfect barriers to entry, so no one can come take that away from you. So I guess as a monopolist, that's why you like to be a monopoly, because you can earn these excess profits that you can't earn in a competitive situation. So here's just another picture for a monopolist. So the next real question then is to really compare how this monopoly situation stacks up against perfect competition. Right? We keep talking about perfect competition being this great thing. Why is monopoly kind of a bad thing from Econville's society perspective? So if we take a look at monopoly versus perfect competition, a key idea is to try and figure out what the supply curve would be. So don't forget, it was a monopoly. We have a demand curve because there's lots of consumers, but we don't have a supply curve because supply and demand model only applies in situations where there's lots of sellers. And so the key idea to understand what happens here is that the marginal cost curve would be the supply curve in perfect competition. The idea is that all these resources would essentially, as long as people could make 0 or higher economic profit in a perfectly competitive situation, they would do that. So that, and we saw this too with perfect competition, that the individual supply curve was the marginal cost curve above the shutdown point. So if we take this as a given, that the marginal cost would become the supply curve, what we could think about in perfectly competitive world, this marginal cost would be supply. And now we can analyze what would actually happen in a perfectly competitive world for this exact same situation. So instead, now we're replacing the monopoly with a bunch of smaller perfect competitors. We have our demand curve here, which is the market demand. We have this swoosh, which would be the supply curve. Well, if in a supply and demand model, how do you find the price and quantity? It's easy. It's where the supply intersects the demand. And so let me just change the color here. So right here, this would be the what we call equilibrium in supply and demand. And so if we trace down in a perfectly competitive market situation, this would be the quantity in a perfect competitive market, and then we would just trace over to find the price here. That's the price in a perfect competition environment. And so now we're positioned to see what happens when you have monopolies instead of perfect competitors. The first thing is, let's take a look at the price side of things. Well, we see here that monopolies charge higher prices. And, that fits your intuition. Most people would expect that and say, hey, what do monopolies do? Well, they probably do charge higher prices, but this model kind of proves out why they're doing that. And then what else happens? Well, the quantity sold in the market by the monopoly versus the quantity sold by the market in perfect competition is lower. And so that's kind of that's like the textbook definition of what's not good for consumers, is that higher prices and lower quantities And so that's a key difference or key impact of having a monopoly. So here I've just moved forward to a slide that lists these monopoly versus perfect competition impacts, and we've already seen this one here, that produce lower quantities and charge higher prices. So that's almost always the case, and that's generally not a good thing for consumers overall, and we'll see that there's a deadweight loss that gets associated with that in a second. Monopolies also earn long-term economic profits, unlike PC, where we know economic profits equal zero in the long term. So that's another key difference between monopoly and perfect competition. And then there's these two sets of inefficiencies that occur with monopolies, and I'm going to go back to the prior slide to show that. So the first thing I'm going to ask you to think about here is, if we think about this graph as what it would look like in perfect competition, we have the red supply curve and this blue demand curve, and that the equilibrium point would be where I showed you earlier. I'm highlighted here in green. Now if we take a look here, the monopoly is producing at a level lower than what would be producing in perfect competition. In some ways it's almost like a quota type of situation, right? The market wants to get to equilibrium, but the fact there's a monopoly stops it. And remember, I talked about how monopoly is also another way to quote unquote mess with the market. And so that's what there's basically these lost opportunities here. If we had perfect competition, this person would buy it and that person would sell it. This person would buy, this person would sell. So there's all these missed opportunities. And just like we would see in a quota, we get a dead weight loss situation to this blue shaded triangle here related to monopoly, because this perfect competition point, there's again these missed opportunities. So there's people that are getting shut out of the market, which is consistent with the fact that the monopoly produces less stuff and charges a higher price for it. Again, it works a little bit like a quota. So here we've taken a look at this deadweight loss inefficiency. The other inefficiency is we talked about something called productive efficiency, which is if you can produce goods at your lowest average total cost, that's a good thing in production. That's good for consumers because that means you're producing at the lowest cost, and you're probably going to be able to pass that on. If we come back to here, we see that the monopoly, this is, I'll draw this in blue here, the productive efficient spot would be right here. So if somehow you could produce at this quantity, you'd be at productive efficiency. But we see that monopolies don't produce at that point. And so, whereas if I draw to the side here, if you remember the long-term equilibrium situation of a perfectly competitive firm, this was marginal cost, this was average total cost, and this was Mr. DARP. We see that in long-term perfect competition, you actually get a situation where you are producing at the min ATC point. So perfect competition gets you productive efficiency, but monopoly does not. And just to close off on this idea of efficiency, we talked about early in the semester that efficiency is when you make someone better off, or you're efficient when the only way to make someone better off is to make someone worse off. And the two really important types of efficiency, which I've already just touched on in this little discussion, but I want to make sure we have the names associated with them, is there's really two that you have to know and be able to identify. The first one is what we'll call productive efficiency, and that's right here. That occurs, you're producing at the productively efficient point if you're at the min ATC. So that's just you're at that low point on the ATC curve. If that's happening, we could say we're being efficient in production. Allocative efficiency is essentially what happened with in the supply and demand model with equilibrium is surplus was maximized. That's what's happening with allocative efficiency. Another way to say it here is that everyone who's willing to pay the marginal cost to produce is getting the good. So the way we'll find allocative efficiency, it's basically where supply, if you could have supply, if it was if you transform the monopoly into perfect competition, where supply would equal demand. Or another way to think of it is where price equals marginal cost, because everybody who's willing to pay that is getting it. And here's just two different graphs to take a look at. And just, so the only reason I'm showing this one is to say, productive efficiency, can you identify where it occurs? Again, productive efficiency, ATC, where does it hit its minimum? Right there. So that would be the Q productive efficiency. So that one's always easy to find once you just remember what the notation means. And then a lot of times in these graphs you need to find where the allocatively efficient outcome would occur. And the way I like to think of that is just where would perfect competition get you. And the way to think about that is marginal cost is really the supply curve. If it were perfect competition, so supply blue equals demand right there. And you can see this is also where price equals marginal cost. Whereas if you look at where the monopoly actually produces marginal cost equals margin of revenue, what's true about marginal cost and price there? Price is going to be greater than marginal cost. So that's what results in the missed opportunities and this in this picture here, again, just to show you the deadweight loss. That would be the deadweight loss. It's the area between the demand curve and the would-be supply curve that's not getting transacted because this monopoly is in here maximizing profits.